Assalamualaikum and good afternoon for Muslim and great for non-Muslim. We from Faculty FTKMP course BMMK want to present this slide. Before we go to present, I want to thanks to Dr. Muhammad Kamil bin Suib to give me opportunity to present this topic. My team include Muhammad Irfan bin Azmi, Muhammad Adi Izham bin Azhari, Lokman Hakim bin Khairi, Azmi, and Muhammad Nail bin Muhammad Nasir. This topic include our syllabus for study BMK 1064 non-conventional welding process. We present topic 6 about hybrid friction stirred welding. I hope you enjoy this slide. Thank you. I want to pass to my friend Muhammad Adi Izam.
Assalamualaikum dan hai, saya Muhammad Izam Azhari. I want to share introduction friction stir welding. Friction stir welding, a welding technique developed and patented in 1991 by TWI in the United Kingdom. And second, friction stir welding be widely used for most slow-melting materials such as aluminum alloy and copper alloy. And third, a solid-state joining process that use a non-consumable tool to join two facing workspace without melting the workspace material. And lastly, the friction stir welding process can join dissimilar material and is also successfully used in the polymers or the more plastic. Introduction hybrid friction stir welding. First, the term hybrid refers to the combination of different types of process in friction stir welding. For example, the laser friction stir welding process. And second, some other hybrid friction stir welding combined process. Third, change in process parameter can also cause the process to become hybrid, such as Jitao and Rivet. 4. Hybrid tool used in the friction stir welding process will provide a lot of new data and produce various results at the end of the process. Lastly, all the hybrid methods are developed based on several factors.
Okay, we meet again. I present about discussion on this slide. We found the friction stirred welding can combine or collab with the laser friction stirred welding and make the hybrid friction stirred welding. We highlight the most important thing in this slide. The material in the laser friction stirred welding using is the AIMG alloy and an I-fall can make the efficiency of the 60% with the 2 kilowatt laser power. And with this material of the Na aluminum and Na2 magnesium can make the ductile compound instead of the brittle atomic compound. Second, the tensile test on the flexible welding using the laser friction stirred welding make the result maximum tensile strength of 169 MPa, which was the 60% of the Mg base metal strength. 3. The hardness distribution of the transfer section of the laser friction stirred welding with the aluminum and magnesium had only slight variation of the base metal. Then the conventional friction stirred joint distribute the higher hardness. Okay, next. The laser stirred welding with the material with S45C steel can pretty effect get the increased welding speed. Focus of the laser beam 10 mm ahead of the rotating tool. When they're using 1.7 laser power, welding defect we observe along the interface line. Overall, laser hybrid can provide the better mechanical and the faster welding speed. Two important thing, better mechanical and the faster welding speed than the conventional friction stir joint. Okay, I pass the next slide.
So Assalamualaikum warahmatullahi wabarakatuh. Today I will explain about plasma that hybrid with friction stir welding. So the result I can get in this process is the weld nugget at varying preheat change. This caused by the maximum temperature and cooling that related to the rotation tool. So other external preheat also play a critical role in this process, that the phase transformation that resulting the size of the grain on the specific material. So we can see here aluminium maximum temperature is 80% and copper is 50%. This process on different temperature produce different melt temperature on both material. So on another slide, with me again, gas tungsten arc welding that hybrid to friction stir welding. So I love this process because it found no defect in this process, because at 300 rotation speed it caused no defect on the material, but after they increase the speed rotation at 400 or higher than that, it caused a little particle, fine particle in the process. So it is because of the excessive heat generation and the speed of the tool rotation that cause of this particle going inside to the weld joint. So another benefit on this gas tungsten arc welding that exists by FSW is the dissimilar material that want to weld. It increase elongation and improve the joint strength by the aluminum alloy and the stainless steel. From the result that I explained from the slide, this table that indicate in the what we observe, the tool rotation speed have 4 different tool rotation speed, 300, 400, 500 and 600. So you can see the travel speed for this process all same, but you can see the surface diagram, it produce different fracture, defect on the surface weld joint, and you can see the cross section also produce different image. So this is all about the G-Tau and G-Tau hybrid to the friction stir welding. For the last slide is friction stir welding that hybrid to the friction stir welding. So they it have 3 different tool. That first is threaded, cylindrical and friction stir spot welding. So these 3 process produce a different tension load that I understand in this case study. So only two procedure or process that is very good is friction stir spot welding and threaded, and the cylindrical not I said is not good, but in it result compared to the FSSW and threaded, this both process give 65 higher maximum shear tension and 90% longer maximum extension at the flexure. So this slide is the result from the previous slide. So this is the diagram for friction stir spot welding, cylindrical and threaded. So as we can see, for the friction it causes flash and keyhole, and for the cylindrical it causes a bigger flash. For the threaded it causes a smaller flash than cylindrical and friction stir welding. So we can say that threaded and friction stir spot welding has much better in this process compared to the cylindrical rivet.
Alright, Assalamualaikum and hi. I will continue with the next slides, which is about hybrid rotating tool. First of all, what is hybrid rotating tool? We all know about hybrid friction stir welding. That is a process using another process such as Jimao, laser gas tungsten arc welding. It combined with the friction stir welding. So in this slide, we will learn about a tool, a hybrid tool that we use in friction stir welding, and we call it as hybrid rotating tool. Okay, from the study we have been done about hybrid rotating tool, there was two types of hybrid rotating tool that we have been discussed, which is the first one is induction heated tool. What is induction heated tool? Okay, to keep it simple, in this process, the friction stir tool during welding is heated by the induction, and the temperature is precisely maintained through a feedback control. The material flow, which is flash, can be controlled by selecting the proper process parameters. This is because changes in rotational speed and temperature greatly influence the flash generation. To keep it simple, change in rotation speed at constant temperature brings a considerable change in flash generation. It also can be inferred that when the rotational speed increases from 1000 to 2000 rpm at various temperature, the tensile strength also increases. At 1000 rpm and tool pin temperature 40 degrees Celsius resulted in minimum flash. This combination also resulted in a minimum strength. At low rotational speed combined with a low tool tip temperature, the heat is insufficient and the polymer does not soften enough, resulting in improper fusion between the seam and the base material. As you can see in this picture, the higher RPM, it will resulting in heavy flash that weakens the weld by reducing its cross-section area. Let's jump into the second one, which is triangular cross-section hybrid tool. In this study, there are two types of hybrid tool that they use for running the friction stir welding process, which is, the first one is conical threaded hybrid tools, and the last one is triangular cross-section hybrid tool. These two temperature profile correspond to the weld joint produced using the conical threaded hybrid and hybrid tools at a travel speed of 40 and 280 mm per minute. Therefore, the hybrid tool with triangular cross-section produces a higher heating rate and takes a longer time for the dissipation of heat to the adjacent base metal. For the peak temperature, welding with the conical threaded tool is close to 350 degrees Celsius, while for the hybrid tool, it was 250 degrees Celsius, which welded at faster travel speeds. Alright, for the weld surface or surface appearance of this tool. For the conical threaded tool, with lower weld travel speed and thus lower weld pitch, has no ripple formation, which could be due to excessive welding heat and steering of the shoulder on the top surface. While when using the hybrid tool, it contains uniformly spaced ripples on the top surface. This is because of the higher travel speed and mechanical shanking effect imparted by the tool shoulder. That's all from me about the hybrid rotating tool. We will continue to the next slides.
Okay, about the finding in this slide, in the hybrid friction stir welding, we got the five important things we highlight the five important things is the tensile strength, surface appearance, the microstructure, wearability, wear speed. First, hybrid friction stirred welding can get the tensile strength higher 20% greater than the normal friction stirred welding. Second, surface appearance can get the workpiece and specimen greatly improved than the other method. Three, the microstructure in the hybrid friction can reproduce the fine and the practical microstructure compared to conventional friction welding method. Fourth, hybrid friction can process the joint variety of the unit and the different material without producing the extreme defect. The defect can be lower than the other method. Five, and lastly, the wear speed in the hybrid friction can reduce the group element with assistance in the two important of the hybrid rotating tool and the laser beam preheating. Okay, I want to pass the next slide. Thank you.
Summary. First, the purpose of the hybrid method is to improve the efficiency and quality of welding. Second, there are several processes involved in friction stir welding, such as Jitao and laser friction stir welding. Third, to summarize, hybrid friction stir welding has shown great promise in overcoming the limitation of traditional welding process. Last, research findings have shown that hybrid friction stir welding can generate high-quality joints with increased mechanical quality, making it a potential technology of future developed in welding industry. That's the end of our slide. I hope you enjoy. Thank you.